The .NET Core podcast is supported by our listeners who have become patrons. To see a full list of the patrons, or to join them, head over to .NETCore.show/patrons. Hello everyone and welcome to the .NET Core podcast, an award-winning podcast where we reach into the core of the .NET technology stack and, with the help of the .NET community, present you with the information that you need in order to grok the many moving parts of one of the biggest cross-platform multi-application frameworks on the planet. And in this episode, I talked with Oren Eini about RavenDB, why he took the time to create his own NoSql database engine, the fact that he built it using .NET Core before it was released, i.e. back in the pre-1.0 days when it was still known as DNX, and some of the optimization stories that he worked on when creating RavenDB. Along the way, we cover what the GC or garbage collector is, performance issues to look out for when dealing with large JSON objects, and some tips that he has for those who want to optimize their applications. So let's sit back, open up a terminal, type in .NET New Podcast, and let the show begin. So thank you ever so much for joining us, Oren. I'm really excited about this because I have no idea what RavenDB is. And if I'm honest, my entire experience with databases has been SQL and SQL-like. And I know from our discussions before we started that RavenDB is NoSql, I believe. So it's all exciting to me, right? Let's talk about this. But I guess, firstly, welcome to the show.
Thank you for having me. Very happy to be here.
Oh, brilliant. I'm glad to hear that. I wouldn't ever want to have someone on the show who didn't want to be on the show.
Mandatory podcast training.
That's exactly it. That's it. Mandatory podcasting. I like it. We need to make that a thing.
Although I do worry where you will get a draft from.
Can you imagine? You've been arrested for something. You've been sentenced to 4 years of mandatory podcasting.
Yeah, the question is what topic? I would do I can talk for 4 years on technical topics, but try to imagine that they give you have 4 years of mandatory podcasting about knitting.
Yes.
Yeah. So leaving aside dystopian futures.
Yeah. So I guess before we start the conversation, Owen, I was wondering, can you give our listeners a bit of a quick sort of elevator pitch about you and the kind of work you do? Is that all right?
Yeah. So I'm Oren. I'm the CEO of a company called Hibernating Rhinos. We have a primary product whose name is RavenDB. I've been a Microsoft MVP for about since 2007 or thereabout. Heavily involved in the open source space in the Microsoft world and in general. And for the past almost 12, 14 years, I've been working on RavenDB. And that started because I was working on the Enable project, which is an object relational mapper. And I worked with data all day long, every day, all the time. And you mentioned that when you think about database, you think about, there is SQL Server, Oracle, Postgres, those sort of things. And for a very long time, that was what it was. Those are the database, and everything else, just maybe some one-off solution or something like that. And what happened to me was that at some point I got looped into the consulting gig and come help us make our system better and those sort of things. And I did that for several years, and I kept seeing the same set of issues over and over again. And I was dealing with databases all the time, so I saw the same problems. And I got sick and tired of that, and I started dreaming, what happened if I could do something better? What happened if there was a better database? That was at around 2008, 2007, and that is the time where we saw the biggest move away from SQL databases, from relational databases. And if you're familiar, some of the names there are no longer there. Riak, Project Voldemort, there was Hyper something, I don't recall. And some of them are still here. CouchDB, Mongo, there is another one that I cannot recall right now. Mindscape, I think, but it's not that one. And all of them were, okay, there are NoSql databases, but they were really tools for very specific purpose. And one of the primary issues that they had was that they gave up a lot in order to do what they wanted. And something that they gave up are things like transactions. Now, if you talk to a developer and you tell them, how can you live without transactions? Then they say, oh, I can do this, I can do that, those sort of things, and that would work. But the problem here is that once you start to actually live in a world without transactions, the amount of complexity that you have to deal with just explodes. And it just wasn't worth it. People said, oh, working with relational database is complex. So let's work with a non-relational database. But now you lost transactions. And that is not a trade-off that I think is beneficial to anyone. So I wanted to have a transactional non-relational database. And by non-relational, I mean, think about the typical mode of operations that how you design a system. Oh, I have a table. If this is a complex entity, I have multiple tables that compose of this entity, stuff like that. And that works, but the problem here is that the more complex your system, the more tables you have, the more widespread your data becomes. So you want to have a different way to model the data. And the industry more or less settled on the notion of JSON document as a good way for data interchange, for representing object graph, stuff like that. And so you have JSON over the wire and in your API, but a relational database that is a wildly different shape in the backend. And that caused no end of problems. So I set up to build RavenDB and as a transactional database that can natively work with JSON. And at the time, I had almost no idea how to build databases. And I say that, and I mean that I built only 3 or 4 at that time frame. That's the like saying I built FizzBuzz or Hello World in terms of databases because I use existing engines and capabilities to do that. And it didn't take a lot of time to figure out that this solved an actual concrete need that people had, that they would be able to simplify the system significantly. And after I had the core project, we started working, what other problems do we have that we can help solve? And some of them are we solve in a relatively unique manner. For example, if you want a database to be fast, you have to use indexing. You have to be able to index to store the data in such a way that the database has an easy way to access and operate that. And that's what indexes actually do. And the problem here is that for almost all databases, you have to tell the database how you want to index the data. And if your data access pattern changes, well, so does your indexes. And that can be an incredibly expensive thing to do in terms of manpower and a amount of attention you have to provide to it. So one of the things that we figured out was that, hey, if I'm the person writing the database, that entity has the knowledge to know what indexes you need. So let's go ahead and create that automatically on the fly. But if you're used to relational database, you go, no, you're never touching the indexes in production. That's the sort of thing that if you do, the system would fall over. But again, you get to design the system so it wouldn't fall over in this situation. And then basically the ball started rolling, and I've been working on that nonstop for quite some time. I think that next year we're doing the 15 year of the first commit for the project. And that's basically me, and very short amount of details about RavenDB.
I like it. Sometimes a person's story is rather encapsulated within the story of the thing that they create, right? So sometimes you know, if somebody says to me, "Hey Jamie, what do you do then?" I can't really say, "Well, I'm a computer programmer," and stop there, can I? You know, I've got to talk about all the other things that are related, right?
Yeah, and the process of writing this database has subsumed a significant portion of my life for the past decade or so. And the interesting thing about that is that I remember not wanting to write a database. Writing a database is a huge task. I had no idea how big it is at the time, and I still knew it was big, so I didn't want to write it. And it kept buzzing in my head, and it wouldn't leave me alone. I remember waking up at 2 a.m. and staring at the ceiling and having, have you seen Minority Report where they do all drag and drop? I had that as UML shapes on the ceiling that shows the process of data flow between a document and indexes, and I'm like, I can't not do that. It was consuming every waking moment and apparently every sleeping moment that I had. Yeah, so I started writing that, and I'm a .NET developer by trade. So I've been working in the .NET platform since the 1.0 version, the alpha version actually, and it was natural for me to go and work with that. And I credit that the fact that I actually started writing .NET meant that I could skip over a huge number of hurdles that I had to deal with because the .NET framework handled that for me. I'm currently in the process of writing a blog post series, and I'm showing how you can write high-performance .NET applications. And I've chosen to write a Redis clone. It has two functions, get and set. That's it. And I wrote that in the most naive way possible. Don't worry about memory, don't worry about Reddit, just write it. The backend store is a concurrent dictionary, and I'm getting a million requests per second. So my goal is to see if I can hit the 10 million requests per second. But the naive version that I got is already so fast, so viable that 100 lines of code give you something that is typically far beyond anything that you would actually need in most systems. And I think that was a major part where I was actually able to build the engine and everything around that. And that was actually something that we managed to build almost 5 years of continuous releases and optimizations and additional features, everything like that. And then I realized that we hit a block, this big wall that we could not traverse because of the way that we built the system. And the primary reason was that we leaned on .NET to do its work, to manage memory, to manage threads, all of those sort of things. And what was the problem there? Let's say that I have a JSON string, and I have a JSON document that represents you, and I want to say, what is your name? So how do I actually process that? Well, I'm going to do JSON.parse, get and then dot name, and here's your name. But what are the actual costs behind that? So I have to parse the document. I have to materialize that into a set of .NET objects, typically a set of dictionaries. And then I have to look up the relevant value. And then I'm going to just discard that, and the GC is going to remove that at some future point in time. And that's, on the one hand, that's magical, that there is so much that you don't actually need to worry about. On the other hand, once you start thinking about a performance, that means that you're now screwed because you don't have control of that. And there is also another issue that we have to consider. Every time that I parse a document, I create a lot of magic objects that then need to be collected. And the more complicated the JSON that I have, the more that cost rises. So in order to manage that, we had to effectively rethink our entire strategy. I remember sitting down and writing here all of the things that we learned from being in production for 5 years. Here are the things that are painful. And I remember going into a production system and doing a support call. And let's look at the percentage of time in GC, and it's 80-90%, which effectively means that I don't have a way to even address the actual problem because I have high CPU, but it's actually because of my allocation rate. And that led to a big issue because the allocation rate that we had to deal with wasn't because of something that we did right now. It's because maybe some other thing that happened, shift in the pattern of access, stuff like that. And we got really good understanding of how the backend of .NET works, how the GC behaves, the trading pool, and everything like that. And then, okay, how can I effectively redesign the system? And the goal was to see if we can design the system in such a way that we are going to play to its strengths. So I know that it's great that the GC cleans up after me, but can I avoid giving it garbage that I don't have to? So we started thinking about all of those sort of things, and many of those things are now standard practice of writing high performance code. So make sure that you have object pooling, make sure that you reuse your buffers, that sort of thing. But because of the nature of the beast, the fact that we're writing a database, we decided to do 2 or 3 very important things. One of them was that we want to own the stack. That means that I don't want to have any significant component that I can't look at and modify. And we have modified pretty much every single component that we have in the system because we have to be able to do that. The second thing was that we said I want to go to manual memory management, which is a really, really strange thing to say because I'm working with that. What does it mean to have manual memory management? And the idea was that we're actually going to allocate memory directly from the operating system, native memory, and use that because the pattern of access that we had in many cases was process a single query, a single request. So we could allocate a buffer and use the memory from that buffer. And at the end of the request, we could just discard the entire buffer as a single unit. Except that we don't even need to discard the buffer. We can now reuse that same buffer for the next allocation, for next request, for next query that we have. Which is amazing because now the cost of GC was reduced to the I have to set the last allocated location to 0 and everything else was freed. This is called bump allocation or in allocation, by the way. And we started looking at that. And some of the other things that we also needed to do, we had to be able to run on Linux. We are a server software. Linux won the server wars pretty much. So we have to run there. But .NET and at that time had no answer for that. There was Mono. And anyone who ever tried to write serious software in Mono knows that you should not. Sorry, I have. It's been dear God, 9 years since the last time that we tried to run seriously on Mono, and I still have the scars from that. And at that time frame, we had DNX, what ended up becoming .NET Core came out. And I made a decision that we want to run on that. And that was an incredibly painful process that time frame. There was no idea. You were writing code in and then compiling by hand, and there was a lot of shenanigans around. You don't have this API, you don't have that API, etc. But we were actually able to run on Linux. We were able to adopt this process of manual memory management and the notion that we are going to move as much as possible of the small and tiny allocation that you keep running into something that is a scope to the appropriate request or context that we're running, and then it's just discarded. And we push on that model a lot. The end result took us almost 3 years of active development to get the next version out. But the benefit of that was that when we were running on almost the minimum that I was willing to accept for the new version was it has to be at least 10 times faster than the previous one. Because if it's not 10 times faster, it's not worth the time that we invested into that. And we actually met and exceeded that goal. So you get to the point where a transactional database can hit 150,000 writes per second and 1 million reads per second on a large scale data. That was just wow for us. And that's it. That's the project, how we got to where we are today.
So you mentioned it a few times, just because there's some people who listen to the show who either are new to .NET or are kind of newish in their journey, and they won't understand what the garbage collector is and why that's a big problem. So I just want to throw this out.
I'm trying. So here's the issue: when you're working with .NET or Python or Ruby, you don't usually think about memory. You say, "I need an array, I need a list," and you get them, and you use them, and then you just stop using them, and someone goes and clean it up. That memory is being released to the operating system. That memory is then being reused. You don't care. The whole point is that there is some other entity that manages your memory. Conversely, if you're using something like a C or Zig or C++, in many cases you have to worry about the details about, okay, I just had a vector of numbers and I used that. Now I want to stop using that. How do I do that? How do I make sure that a memory is released? How do I make sure that this memory is released even if there has been an error? And because if you don't release all of that memory, that means that, hey, you know what's going to happen? You have a memory leak, and that software is going to be a nasty way to spend a couple of afternoons trying to figure out where you missed one code part where, I'm allocating here, but I never actually imagined that during the second phase of allocation, I would run into an error, and then I'm not actually releasing the memory and all much of other stuff like that. And the garbage collector basically fixed that. This is the whole notion of automatic memory management. Where is the problem with that? Automatic memory management does not mean free. And one of the things that you have to realize that the cost of garbage collection is proportional to the amount of memory that you have in use. Why is that? Because effectively, at some point in time, the garbage collection needs to make a decision. I need to collect all of the memory that you allocated that you're no longer using. And the way that it does that is it runs a scan. It goes through all of the memory that you have in your system and try to see if that memory is reachable. So let's say I have a static variable. I have something on the stack. And I can start, and those are called roots, and I'm going to start from those roots, and I'm going to walk the entire set of the entire object graph to find all of the reachable objects. So the more reachable objects you have, it's ON to that. So the more reachable object you have, the more you actually have work to do. And that leads to some interesting observations. Here is an interesting optimization that we had to do in RavenDB. We had, if you would disable the cache, memory utilization and CPU utilization would drop down significantly. So if you use the cache, RavenDB would use more memory and more CPU than if you did not use the cache. And on its face, it makes no sense. How can that be? And then you realize that the cache is also keeping the managed memory rooted. So the more items you have in the cache, the more reachable items you have, the more the GC had to do work to do to scan. At which point it would scan objects and try to and say, oh, I cannot release anything. Okay, next time I'm going to do the same again. But in order to handle that, the GC has this notion of generations. So the typical heuristic says that either I allocate some memory and I'm immediately going to forget about it and never use it again. This is called the young generation or Gen 0. Or I'm going to keep it for a very long time. So it's going to end up in the old generation or generation 2. So what happened is that every time that you have a survivor from a garbage collection, the GC, the garbage collection, is going to move that to the next generation. The idea here is that we want to reduce the number of items that we're going to scan. And the more GC you have, the more items end up being in the older generations, which means that those scans become more expensive. So just the fact that I had a cache that was usable and kept things in memory for longer meant that I would pay more in GC cycles. I would pay more in CPU. I would also pay more in terms of the memory used. Why is that? Which is ridiculous because the whole point of cache is to trade memory for CPU. But what happened, or some computation, what happened was that the cache, the memory that we used was filled to the brim with cache entries, at which point the cache would start evicting items. But those were items that were already on Gen 2. So it would take even longer for them to be removed, at which point I would add more item to the cache and the cycle continues. And I remember when we realized that this is the case, that was a consequence of a series of absolutely legitimate decisions. The way that the GC work, generations, caching, all of that. But all of those decisions together means that if you enable the cache, the performance is going to drop significantly. And that's non-obvious in the extreme. So there were quite a lot of issues like that we run into. I mentioned the JSON parsing as another example, where the amount of managed memory and the number of items that you have in the object graph is basically affected by the user. And it's relatively simple to generate a 1 kilobyte JSON file that would, when you parse that, would consume a megabyte of managed memory, which is a bad place to be at. So what ended up happening was that we took all of those things that we learned, and then we figured out how can we avoid them. And the answer to both of them, and many of those problems actually end up being the same solution. So instead of storing data as JSON strings, instead of parsing that into a managed object, we actually have a serialization format, we call it Bleatable, that allows you to store JSON data in a format that is immediately accessible. Because I get some binary data, and I'm going to say, okay, give me your name, and then it's going to know, oh, I need to jump to this particular position, and I'm going to get the name and everything else around that. And then you have, oh wait, if this is just raw binary data, it should not be in managed memory. It could be in native memory where it's transparent to GC. So I may have thousands of those items, but it doesn't add up to the cost at GCC. And then we even took it further and said, hey, one second, this is just a buffer. I can use a memory map file, and instead of doing things like reading from the disk and stuff like that, I can say, oh no, what I'm going to do, I'm going to just memory map the file, give you a pointer to the specific location in the file, and let everything work from there. So we actually managed to integrate 3 or 4 different layers of solutions to problems that we had into one common goal. And then it started spreading from there. And we actually ran into some really interesting issues. For example, when we start writing the new generation of RavenDB, we had unmanaged memory, and we need to write it to a socket. But the only API that you have in .NET at the time to write to a socket is a stream, and a stream accepts a byte buffer. So we had to jump through multiple hoops where we would have the native memory, and then we write it to a byte buffer, and then we write it to a stream, and it was still faster. And now we have span and memory that manage that directly, so we don't have to think about this. But it was, we actually see how the DNX came out, and eventually you had .NET Core, and it was open source, and they accept contributions. And you could always look at the source code of .NET. Either you had the shared source initiative, or there was a .NET Reflector, which is an amazing tool, was an amazing tool. So you could always go and pick in and figure out what's going on. And the difference was that now when you had a problem, you could fix it. And previously, you would submit a bug. And if you were lucky, it would get fixed in 12 to 18 months. Which means that effectively this was nothing. There is nothing that this is no longer. There is a bug. There is always going to be a bug. It's not, the fix is not relevant for you. And now you have the ability to go into the code, fix that, run your own version if you really want to. But if not, then in 3 weeks, 6 weeks, you have a version that's acceptable. That's something that you can live with. It's even more interesting when you consider that the barrier for making a change in .NET previously was however many people you have in the .NET team. Whereas now it's however many people can get their PR merged. So there was a huge amount of chores that you needed to do. And suddenly you had the community that everyone, I really don't like that there is in Stream Reader there is an allocation. There is an allocation of about 6 kilobytes of memory every time that you allocate a Stream Reader. Why? Because it does buffering and not much of other stuff like that. No way to fix that. But then it was open source and it was fixed. People say, oh, I have a problem here, and I can submit a PR and get it accepted, and it's going to work. And if you look at the .NET release notes, you can see always, there is this fix, there is this fix, but and sometimes they are big. The spanification of .NET was a huge issue, for example. Value task is a huge issue. But in many cases, let's optimize link operations to specialize for this particular scenario. Those sort of things. And those sort of things ends up this sort of cascading effect where you end up shaving some percentage from here, some percentage from here, but then you look at the overall ecosystem and, okay, just upgrading the version, you have a major performance was 10, 20% in some cases. Another thing I think was really great with .NET, .NET Core versus the .NET Framework, you could have your own version of the framework. So previously you would have whatever is installed on the machine. And every time that you had to update, that was this big risky thing that you would have to do. But now I get to say, oh, no, I don't care what version you're running. Your code runs whatever you want. My service has its own version of the .NET Framework that is private to it. I can deploy it separately. I can version it on myself. Just to give some context, right now we have multiple versions of RavenDB out from 4.2 to 5.3. Each one of them is tied to their own .NET version. And that simplify development and deployment concerns significantly.
There's a huge amount of stuff that you've said there that is so far. You've talked a lot about like the optimization path and stuff. Mm-hmm. I love the idea of being able to ship my application with all of the bits that it needs, right? This sort of self-contained deployment. And I love that we could do that with .NET. That's fantastic because you can have, like you say, you can have the globally installed version of .NET, but you can also have this is the local version. Let's say you've got .NET Core 3 installed globally, but your application needs .NET 6. Well, you ship it with .NET 6 as a self-contained release, and it will use that version. And I also like what you said about all of the innovations that we get for free, right? The community may come up with an idea. I believe, now I may be wrong about this, but I believe span of type T that you mentioned a few times was a community idea. And it was, I mean, I may be wrong, but I feel like it is. And that was just sort of adopted. And like you say, the team at Microsoft then went through the entire code base and spanified it, right? They were like, let's use span everywhere instead of, buffers or streams or whatever. In places, and just that stuff that we get for free is amazing. And I feel like because I was going to say when you were talking about all the optimizations you were doing, the back of my head I was going, what about spans? Have you tried spans? And you've already done it, right? But I feel like it might be relevant to say to listeners that a lot of the optimization things you're talking about that you've done for RavenDB are, whilst they might be good to have in any application, I feel like a lot of the things that you've done are very kind of specific to RavenDB. Yeah. What I don't want is for people to come from this episode and go, I've made it a do app, now I have to optimize it at the same level that Oren did for RavenDB.
So I teach cloud computing course in university. And I was just talking to some students as, we have to make sure that the system is scalable and can handle lots of requests. And one of the things that I asked them was, how much is lots of requests? And they had no firm answer. No, they're students. They don't necessarily have to know everything. But building a system that can do 10,000 requests a second is quite simple. You don't need to go crazy. If you want to go to the 100,000, to the million, you have to do some work. But again, I wrote 100 lines of code to simulate Redis, and I hit 945,000 requests per second in the most naive possible way that I could think of. And the typical way that you want to approach those sort of things is, what am I trying to optimize for? Am I trying to build a system that's going to be hammered by lots of requests and have a very short latency to process requests? Okay, that's one thing. Am I trying to optimize the latency of delivery? So am I trying to make sure that I can make changes and push it to production and have to optimize that pipeline of user requests to it's live in the air. And in most cases, I would say that unless you have a strict requirement and the need to actually have high performance, don't worry about it. Don't worry about it because in most things that I've sold, it's far more the things that slows you down are not necessarily the intricacies of the interaction between caching and the GC, but more, you have n square algorithms here that you never considered. Or, here you need to load 6 items from the database. You go to the database 6 times instead of once. And that sort of things. And the old adage about, make it work, make it work right, make it work fast is true. That said, in many cases, you can say upfront, what do you want? What are the requirements? And then you can design your system accordingly. Here is a relatively simple example. Going back to the Redis example, I'm reading strings from the network. That means that I have to do a lot of allocation. When I parse in the string, I have to do more allocations. I can read them as bytes, but as a byte array. But then I have a question: how do I store the keys and the values? Do I store them as managed objects? Do I store them as native memory? How do I make sure that no one is referencing memory that hasn't been in use yet, and a whole bunch of other stuff like that? And it's very easy to take upon yourself a lot of complexity that you aren't necessarily aware of. Manual memory management means that you have far better control of what's going on. But if you look at something like concurrent dictionary in C#, it's nearly impossible for you to write something similar in C or Zig or Rust or C++. You have to use something called epoch-based garbage collection, which is an insanely complicated way to say you have a garbage collection in a language that does not support it. And that's not trivial. There are a lot of things that the GC makes possible. Another thing that I think is really important to understand, in most applications you have hotspots. You have the things that you spend most of the time doing. And optimizing them give you the most bang for the buck. And one of the things that I love about C# and .NET in general is that I have the option of saying, here I'm using structs and span, and I'm doing no allocation whatsoever, because this is the heart of what I'm doing. And in here, I'm just going to do strings galore, and I don't care because this is going to run once an hour. Or this is the sort of things that happen during system startup. Yeah, not that an important consideration for me.
If you're enjoying this show, would you mind sharing it with a friend or colleague? Check out Podcatcher for a link to the show notes, which has an embedded player within it and a transcription and all that stuff, and share that link with them. I'd really appreciate it if you could indeed share the show. But if you'd like a few other ways to support it, you could leave a rating or review on your podcatcher of choice. So if you head over to .netcore.show/review, you'll find loads of ways to do that. You could consider buying the show a coffee. The Buy Me a Coffee link is available on each show's show notes page on the website. This is a one-off financial support option. You could become a patron. This is a monthly subscription-based financial support option, and the link to that is included on each episode show notes page as well. I'd love it if you could share the show with a friend or colleague, or leave a rating or review. The other options are completely up to you, and are not required at all to continue enjoying the show. Anyway, let's get back to it. Oh yeah, absolutely. I think that similar to what you'd said when you were talking to those students who were like, "We need to make it hit, survive 1 billion people hitting it at the same time." When people come to me like that, I'm like, "Well, I mean, do you have 2 users yet? You might be optimizing a little bit too early,
At one point, I got a request from customer. Oh, we wanted to work to be scalable. I asked for numbers. Oh, just make it work like Google. And I says, okay. And I went into the SEC website and pulled the quarterly report for Google, and I gave them a quote for $50 billion, something like that.
Yep.
And apparently, I somehow broke the system because the fact that they had a quote of this amount apparently broke a lot of reports and made a lot of people very angry. And my point was, okay, you want me to make it like Google. Here is the Google budget. I don't want the whole budget. I just want the quarterly budget. I will make it work as you want. And I got the point across that, you get what you pay for. And if you want to be able to scale to 1 billion users, you're probably not going to do that on a shoestring budget. And sometimes sometimes you have to make that determination. There's another issue here, especially when you're talking about people who are starting out in startup stuff like that, where their expectation is that, oh, this must be scalable. We have 0 users now, but we must be ready to accept 10,000 users on day 2.
Mm-hmm.
And the problem here is that what do you get for what is the cost of that sort of behavior? And I found that in many cases, by the way, if you find yourself in this situation, there is a relatively simple way to fix that you can ignore performance, but still be able to scale and still be able to deliver very quickly. And that solution is to put the behavior that needs to scale behind the queue. So let's talk for a second about, let's say that I'm accepting, I don't know, images from an app on your phone that is, and we have to do image recognition on that and say whatever this is a stolen piece of art or not. Shazam for a painting, whatever. Well, I can try to create a highly optimal system. I can say, I don't care. What I'm going to do, whenever you upload an image, I'm going to throw it in the queue and have someone process that. And at that point, I have people who are upset about me. Well, how does it solve your problem? But let's talk about a relatively simple scenario. I have a piece of logic that I need to run, some computation on the data. And maybe many users would provide me this data and I have to do all of the work around that. Well, what about if I throw that into a queue? And instead of trying to process that inline or I just go and throw it in a queue and process that in the background. In the background, I'm not going to try to write something special. I'm going to plug this into an Azure function. So you have a queue, and every time that you put something in a queue, it goes into Azure function. And then the Azure function runtime itself is going to spawn however many instances that it needs to process that. And so a lot of the complexity that is involved in actually running and managing that are just not there. They are, someone else already solved them for me. And then, and again, the holiday is that I get the nice development experience. And if there is a need to scale, then the Azure runtime is going to handle that for me. And at some point, oh, you know what? We're spending a lot of money on Azure on all of those function invocations. Then I can sit and try to optimize that. You know what I can do? I can do something even nicer. Let's add another listener to the queue and write all of those items to the side. And then I can take all of those items and run the same working set that I just had in production under a profiler. And typically I would find the ON square that I have there or something like that, how could I be so stupid to miss something like that, and fix that, and the function bill, the amount that I'm going to pay is going to drop by some 300 percentage points. And those are not a random number that I'm pulling. Those are real things that I've seen. And from the all of that starts from the concept that every time that I know that I have something that I'm going to have trouble scaling, I'm not going to try to do it inline. I'm going to throw that into a queue and let the queue manage that.
And that all makes perfect sense to me. I feel like because we've talked about optimizations, I feel like this is a conversation to have. I feel like modern system architecture might not necessarily be the best way to do stuff, because I feel like, in my opinion, right, we developers like to leap directly towards what's the most complicated way that I could build this system, right? I see so many tutorials online that are like, I built a blog, a static site blog using Kubernetes and, JavaScript and, JavaScript's not complicated, but, it's Kubernetes and Node and Docker, and it has 100% uptime except for when the server that's hosting
Steve, all of the 300 pods on that is down, and in order to deploy or to make a change, it takes 3 hours and a PhD in computer science to figure out what the YAML file is going on. And the problem, developer wants to work on interesting things. No one wants to work on the boring stuff. And I think that this is the difference between a developer and architects, where a developer wants to work on interesting things, and the job of an architect is to make it as boring as possible. But a lot of things that we are now facing in terms of complexity, the type of application that we've been in haven't significantly changed in the past decade or so. So, we are building a lot more APIs to manage applications, but not that difference than before. A major part is, and the difference is the sort of qualitative difference that you have to provide. Well, before, 15 years ago, I have a startup idea that you would scan on the phone, order for invoices, and we will submit your own expense report for you. That's an idea. I can build a startup on that. Today, well, I can give that as literally a class assignment and expect my students to complete that over a weekend. And because this is something that you now have available and democratized, then you now have a lot harsher pressures to deliver more. And at the same time, we see a lot of people spending a lot of time on infrastructure concerns that makes their system so much more complicated. If I'm looking at, I have a issue with Kubernetes and its complexity, because I'm saying, okay, if you're deploying to on your physical hardware, then it gives you some advantage. But if you're working on the cloud, there is almost no difference from a conceptual perspective between a Kubernetes pod and a virtual machine that you got from the cloud. They're one and the same. So the Kubernetes API is cross-cloud, and the cloud API is specific for the cloud that you're using. But beyond that, now, on the other hand, you have the notion of containers and the ability to package the entire environment in one shot, which is a major improvement, because otherwise you would have to figure out what all of your dependencies and all of that on your own, and that was not a fun game. I still remember where we used to do lift and shift. So you take a physical machine and you just copy it as is into a virtual machine by cloning the hard disk, because no one knew what sort of secret dependency you had that had to be just right for something to work.
Yep.
And now you can just throw all of that in a Docker file and it's working.
Mm-hmm. Yep. And yeah, my go-to thing that I say to people is your boss, client, user, whoever it is that's paying or investing either their time or money or whatever, do you making this thing? Do not care how you made this thing, right? They're not going to be excited about the fact that you use Kubernetes and a million pods and you've used a sharded database and there are functions and you went cross-cloud and you did all this stuff. All they care about is when I click the button, does it do the thing, right? So my goal is make it so that when I click the button, it does the thing first.
Yeah. Here is an interesting observation. We built the user interface for RavenDB using single page application. Now, I have to admit that the last time I built web applications, I believe that the proper way to do formatting alignment of stuff was to put everything inside the table. And apparently the UI technology that we're using is Knockout, which is now out of date, doesn't work, whatever. It's still working. Everything else is just fine. But we have users say, no, why are you using this outdated technology? It's working and we have a significant amount of code there. Oh no, you have a legacy database. Legacy. It's not legacy. It's perfectly fine working code, but people have this impact on that. And the moment that you start chasing the new thing, I can do this, I can do that, and everything, then you end up being in a bad position in a short amount of time. Think about people who bet the farm on Docker, and Docker is currently not a healthy company. What is it going to be the state in 3 years? Kubernetes is huge right now, but give it 2 years and probably the focus will be elsewhere. Do you still want to edit all of those YAML files in the end? And there's also there is something called the complexity budget that you have in your project. And the serious question is, where do you want to spend that complexity budget? Are you going to spend that on your infrastructure? Are you going to spend that on solving a business problem? And I don't have a appropriate answer because all of it depends on what are the priorities for the user. Here is a great example of, I know a person who spent 3 weeks defining a set of Kubernetes scripts and models that they can use. So in the end, they click a button and they have an application app and it integrates to Let's Encrypt and deploy to multiple clouds and much further stuff like that. And it took them 3 weeks, and someone doing everything manually would have taken less than a day. Their role in there, their thinking there was that I'm a project company. I do a lot of projects. It's worth my time to optimize for that particular scenario because I do that all the time. But in most cases, is this where you actually gain the benefit? Another thing that is also super important that we learn the hard way is, okay, you have this cool new toy. How does it operate in production? How do you monitor, debug, and operate that? And that's something that I think people don't pay a lot of attention to that. Have anyone who ever tried to debug the ingress behavior of a Kubernetes, or why do we have this particular pattern of calls or stuff like that? And you suddenly have so many different components in the system that have to play together in order for something to work, and they break. And now all of the abstraction that you were relying on has to be peeled off in order for you to understand what's going on. It's insane level of cost that you're going to end up paying.
I agree. I agree completely. And the worst thing you want is, like you were saying, right? you heavily invest in this technology during like an early phase, and then in 2 years' time, you've gone past your MVP status. You've got your application out there. It's making some money. You've sold it on or something, and the technologies that it's using, just like the people who were creating it, just go out of business, or there's no support for it. Right? You don't want that, because you need to continue to evolve your project, right? And that's it. I feel like that's more of a long-term, like you say, maybe an architect decision or a business decision that a lot of developers don't really easily fall into. And I feel like it puts you in that position where, see, okay, so personal story, I have an apprentice, and yes, we're recording this in 2022, and I had the apprentice build a WinForms app, right? Yeah. Because the goal was not, let's build a WinForms app. The goal was, let's learn a whole bunch of principles. And they already had loads of experience of building WinForms, because part of the course that they've been doing has been WinForms. Whether they should have done or not is a different decision, right? But it also meant that, at least at the time of the recording, there's 22 years of documentation, examples, blog posts, and videos that they could fall back on if something doesn't work. Right? Yes, WinForms has kind of fallen out of vogue, but it's still supported by .NET 6, and there's 20 plus years of resources.
You know what? That's a great example. So WinForms has been it's basically take the Windows Win32 API and expose them outside. So if you were aware of the Win32 API, you have a very smooth transition to that. Now, let's say that you actually built an application using WinForms. What does it mean? Well, it means that your application for a very long time could run on Linux. It means that you don't actually care about things like MUI, MAUI, however you say that, or or WPF, or there was UWP, and I don't even remember the name of all of the UI framework that were pushed by Microsoft just in the past decade. But you were running on WPF, then you're stuck on Windows, and maybe there is Avalon that might help, and now there is the MUI that might help. But if you're running on WinForms, it's there, it's working. There is no hassle in cross-platform. There is no hassle in actually building. Maybe you don't get it to be as pretty as you could with WinForms, for sure. But the entire system is stable. Now, here is another important aspect. You mentioned that the company may go out of business, but whenever I have something that is specialized, I have to consider also the manpower requirements. How much is it going to cost me to get someone who is specialized in this technology if the person that I have working on that is not available? They quit, they took a leave of absence, whatever. So do I have anyone else that can debug this Kubernetes CI pipeline? Or is it, he's off, I don't know how to do that. No one knows how to do that. And at one point, I remember I was working for a payroll company, and the payroll company had considered some data to be ultra sensitive, so they wanted to encrypt that. And the encryption was done using some guy who wrote an encryption algorithm of I have no idea what quality. And their problem was that they considered the encryption to be secret. So he actually stored the code for the encryption algorithm in a USB thumb drive that he put in his pocket. And every time that he left the building, he would put it in his pocket and leave. That was the secured way of doing that. Coincidentally, by the way, he was fire-proof. I have no idea why. And but that was a great example of a particular choice sticking you into a dead end. But but at the same point, let's say that we're talking about cryptography. And cryptography is a great example of an area where you need to have the expertise. You probably don't have the expertise, and messing up can have catastrophic consequences. So again, you choose what the wisdom of the crowd say, because the data has already been vetted. And in many cases, the boring old technology is the one that you want to use because it's predictable, it's understood. The failure modes of that is understood. I can go and ask pretty much any Win32 question and put it into Google and have an answer.
Mm-hmm.
If I'm using a framework de jour right now, no idea.
Yeah. And so, like, with this apprentice, we are, if there's time during their apprenticeship, going to migrate to .NET MAUI, but only if there's time and if the documentation is there, right? Because I was talking to a friend a few days ago at the time of recording, and he said, you've got to be really careful because some of the documentation for .NET MAUI exists, but because it's evolving so fast, it's wrong.
Yeah. Yeah, and there's nothing. So senior people are used to. Okay, I might need to do a little bit digging. And one of the things that I love to do is, okay, let's go and look at how this is actually implemented, so I understand better what's going on. But someone who is starting out and the documentation is wrong, or therefore there's a documentation bug, well, that sucks. And sometimes that sucks a lot, and they don't see that. And I think a major difference between, in terms of experience, is just being able to read the error message. I had someone who were trying to do some process where they automatic SSH automatically into a machine, and then deploy some stuff, and etc. And that was really interesting because it failed. And the reason that this failed was that they were writing that on Windows, and they piped /r/n into bash, and it didn't handle that. And there was something in there that says that, and I was able to look at this. Oh, the problem is here, but they wouldn't see that.
Mm-hmm. Yep, it is a very important skill. I remember I have a similar story. I was working with someone a number of years ago who was new to .NET. They were flying as they were picking it up, but every time that an error happened, it was almost like they'd throw their hands, like a compiler error or a runtime error. Their hands would get thrown up, and they'd say, "That's it, I'm out. I can't do anything about this."
Yeah.
And I would say, "What does the error message say?" "Oh, well, it stopped on this line." No. What does the actual error message actually say? And like you say, there's a skill involved in parsing that information. And at least with C# and JavaScript and these sort of modern higher level languages, those error messages are really good, right? I would love to take someone who's struggling with a .NET error message and give them something that's written in C and say, right, it's broken. Here's the error message. Good luck.
You know what? Here's a great. I remember the year is 2001, I think. I wrote my first C# program. At the time, I was writing in C++, and I wrote something like that: a public class form1, static void main, and I had a field variable called form1, and I did f.show, and it died. It didn't work, and I could not understand what's going on. There was some non-reference exception, but okay, this is alpha, beta code. I don't care. It's probably broken. And then a few weeks later, I remember, wait, I had this misunderstanding conceptually, because I was writing form f semicolon then f.show, and I was writing in C++ where this is not this would actually be a stack allocated value, not in C. This is actually a pointer. So I went and actually did form f equal new form and then f.show, and then it worked. And then I went and wrote the same thing in C++. Form star f.show, or f error show, and I compared the errors. And in .NET, it was $first exception on line 23. In C++, it was access violation exception, try to read 0x, you don't going to, you're not leaving tonight.
Mm-hmm.
And I mean, that experience, that particular experience, and it's been 20 something years, is the reason I started working in .NET, because of that sort of behavior.
Mm-hmm. It's it's something that I try to impress on juniors, apprentices, mentees, is that it may not initially be easy because you're learning all sorts of other stuff when you're learning a new programming language, but the error messages are your friends, right? They will tell you almost precisely not just the line but the character where that error happened, right? So it'll say like line 12 colon, it'll say like a null reference exception, file name 12:3 means the 12th line, third character in. It's like pointing you exactly where you made the mistake or your misunderstanding is. And I think that's like you say, I think it's not an easy skill when you're starting, but that is like the one of the most important things I think that juniors should spend time on, not learn, but spend time on, because I'm not saying you have to learn this. I just like spend some time with errors, make something break and see what it looks like.
It's another important skill is when you write your code, throw the right errors, because I see if something is not there, throw exception, new exception.
Mm-hmm.
What am I supposed to do with that?
Mm-hmm.
What happened? Why it happened? How could you fix it? Write it out. And in some cases, you spend more on error, not error handling, error crafting
Mm-hmm.
to do that.
Absolutely. No, I agree with you completely. I feel like personal opinion. I feel like the system exception class should be like a base class or an abstract, so that you can't use just the basic one. You have to use a very specific one, right? But that's my personal opinion, based on several years of building frameworks and applications. Because if you just throw a new exception, it's pointless.
I actually don't care that much about the exception type. Give me the description. What's going on. The great example is that if you write a C++ program, and not if you write a C program, and you run it and you get an error, e-file permission denied, e-read only. Which file?
Yep.
And suddenly you realize that in order to get good error handling in C, you have to be on infrastructure. A great example there, if you go and look at OpenSSL and how they do error handling, then they actually have sort of like exception, but in C, where you can push items into an error stack, and then you can pull that, and okay, great, that's wonderful, but that's just the baseline that you need for proper requirements, for proper development over time. Otherwise, there is I have no idea why. Go look at the log file. Try to correlate the time frames.
Yeah, I agree. What I will say though, Oren, is I'm very respectful of people's time, right? And I know that I'm kind of dropping everyone right at like this exciting part about exception design, and maybe we can come back and talk about that another time. But because I'm using up a lot of your time this afternoon, and obviously it's a big ask for the listeners to listen through a long conversation. It's a very in-depth conversation. I've learned a lot so far, but what's the best way for folks to find out about RavenDB, maybe a little bit more about yourself? Where can they go to find these information?
For myself, go to ayende.com, ayende.com. That's my blog. I've been writing there for 18 years or so. For RavenDB, ravendb.net. This is the source and everything in there. And if you have any questions afterward, feel free to also email me. at ayende@ayende.com, and I will be very happy to answer any queries.
Excellent. Well, like I say, I feel like I've kind of interrupted you mid-flow there, but I'm also, one of the things as a podcast host is you've got to be really, this is peeking behind the curtains, right? You've got to be very involved in the conversation. You've got to be very involved in where the conversation is going, but you also have to be very respectful of your guests' time. And we're almost out of time for the time slot that we created for this. So I'm just trying to be very respectful of that.
That's perfectly okay. Thank you very much.
Hey, no worries. What I want to say, Oren, is thank you ever so much for being on the show. Because I say this to everyone, and almost every episode ends with me saying, I really appreciate the time and you sharing your knowledge, but I really honestly do. I feel like there's loads in this so far that folks are going to be able to listen to and go, oh, wow, yeah, that's a great idea. That's a great point. Or maybe, your points about why are you optimizing too early? Or, you hinted at it, I think, but we didn't really specify about making sure that the things that you need to optimize for are measurable. Because that's
yes. Yes. Just one last thought. If you're building any sort of system and you're talking about performance or a scale or something like that, start by defining an SLA, service level agreement. And a good SLA looks like this. 99.9% of the request of a particular type would complete in a given time frame, let's say 200 milliseconds, as long as the number of users that they have does not exceed 500 users per second. Something like that. Because that is actionable. That gives you a way to measure, and you can monitor that. Anything else is just pulling a finger, licking a finger, throwing it in the wind, see where we're at.
I agree completely. And it goes not just for developing apps, but like, let's say you're trying to do something else in your personal life. It needs to be measurable, because otherwise you're just saying, oh, well, like if I said I want to learn Mandarin Chinese, right? Mm-hmm. Well, that's great. But how much of it do you want to learn, in what time frame, and how are you going to show that you've learned that much, right? That's way off base for programming, but I feel like it's the same thing, right? If you have an SLA or some goal that you're going to hit in a specific amount of time, you said that, X number of users, the request has to take less than this much time for a specific group of users, and that makes perfect sense. You're locking that down. You're saying this is what we're aiming for.
There is a whole range of research around gamification of activities. And a large part of that is the moment that you have measurable goals that are concrete and actionable, you're going to hit them, or at least you're going to try. Most people will actually hit them. That makes a world of difference.
It does. And I feel like we should leave the listener with that, because that's a great place to leave it. So it gives them something they can action on and actually improve their development practice, I think. I said it earlier on, and then we had this wonderful conversation about gamification and specific measurable goals, but I really have enjoyed this conversation, and I feel like there's loads here for the listener to really get out of it. So I want to thank you from me, and I feel I'm being a bit presumptuous here, but I want to thank you from the listener as well.
Thank you very much. It's been a pleasure.
Thank you very much. That was my interview with Oren Eini. Be sure to check out the show notes for a bunch of links to some of the stuff that we covered and a full transcription of the interview. The show notes, as always, can be found at .netcore.show, and there will be a link directly to them in your podcatcher. And don't forget to spread the word. Leave a rating or review on your podcatcher of choice. Head over to .netcore.show/review for ways to do that, or to reach out via our new contact page. And to come back next time for more .NET goodness. I'll see you again real soon. See you later, folks. The .NET Core Podcast is a production of RJJ Software Limited.